can solve these. You have to be an expert at solving these. So this one we don't have to do full cross multiplication. We can get rid of this, divide by 7. Yep, 7 times 6, divided by 3. Are you serious? You guys haven't found this yet? Maybe you need to listen and pay attention. X equals 14. Okay, next one. Full cross multiplication is necessary because m is on the bottom. So we have to do the opposite of dividing, multiply on the other side. 21 times 2 equals 3 times m. (42) equals 3m. So then m will be 42 divided by 3, exact same value. Now on this side, properly, I should have rewrote it as x equals 14. It doesn't matter to me if you have x equals a number or number equals the letter. Okay, so those two are written different, but that's fine. Any questions? Every question you do today is going to come back to these two examples. So have them out, make sure you can answer them. What we're going to see, though, is we're going to see 3 fractions. What we have is 2 separate questions. So we can use these two fractions to find x, and we can use these 2 fractions to find y. So we can rewrite it separately. 1 over 2 equals y over 8. X over 4, so I'll use blue. X over 4 equals 1/2. Solve for x and y. Go. Hands up if you got x equals 2, y equals 4. Perfect. Now what we can do, if the variable's in the bottom, no big deal. It's exactly the same as what we've done. We're going to move on to a harder question. Pardon me? Yeah, for this question, number 2 is just like question number 1. Okay, so what you want to do with this one is set up one ratio to be the first 2 fractions and the second ratio to be the last 2 fractions. The only difference is y is on the bottom, but no big deal because we've already answered those up above, for example, number 2. Okay. For question number 3, the order's kind of mixed up. We know both numbers for the first fraction. So, you're at your choice. If you want to rewrite it, you can, but you don't have to. Okay. This one's easy. You can see these two being equal. So we have 1 over 9 equals y over 27. For the second one, any ideas on what we can do? Andy? Pardon me? Find y. What about this 3x, though? Yep.
Well, as soon as you find y, you can use the y value in the second.
Good idea. Yeah, find the y value. But since they're all equal, how about we just rearrange them? They're all equal. It doesn't matter which one goes first, second, or third. So we could simply move this one right into the middle and get y over 27 equals 1 over 9. That's correct. Nothing wrong there. And it also equals 3 over x. Right? Since they're all equal, it doesn't matter which order we put them in. Now you should be able to see that here's the first one, and here's the second one. So now you can solve for x. 1 over 9 equals 3 over x. Solve for x and y. Go. How many people got y equals 3, x equals 27? Perfect. Now what you can see, hopefully, is that what we can do is make these two equal as well as having these two equal. So you don't have to rewrite. As you write the two ratios separately, for example, right here and right here, you can go from the question right to those ratios. So you don't need to rewrite. What I want you to do right now, so I want you to answer question 7. Okay, let's answer question 7. Actually, no, check that. That's not what I want. Let's do question 8. Question 8, okay? Answer question 8. Rewrite it to separate fractions. They're all equal to each other. Brody, do you have a problem? Okay, so for this last one, because I had decimals, I didn't want to use the multiplication dot. So I just used brackets to show multiplication. Okay, so brackets beside brackets indicate multiplication. Let's do it. Triangles can be enlarged or reduced. That's too slow replying to the email, Brody. The two triangles keep the same shapes, they have the same angles. No angles will be changed, but the side lengths are different sizes. And that's why they've enlarged or reduced. We say that these triangles are similar, not equal or congruent, but similar. We can use the known measurements to set up ratios and or proportions. So those scales, those are the scale factor. Ratio scale and scale factor can be used to find the missing sides. And that's kind of where we're going with this. We're finding missing sides. In the box, really important, star it. Triangles are similar if they have equal angles or if the corresponding sides make equal ratios. So if you have one, that means the other is true, kind of like the circle properties. Okay. So, triangles basics. Angles, corners, vertex, or vertices are labeled with capital letters. Angles can also be labeled with 3 letters. For example, if we have a triangle ABC, angle A also equals angle BAC. Okay. So the angle can be one of the two. Notice how the vertex is the name. Okay, so angle A is angle BAC. Sides are labeled with lowercase letters. They can also be labeled with 2 capital letters. So you have a variety of ways of describing the sides. Now the side opposite must be labeled with the same letter. Okay, so if we have triangle ABC, that's 2. Opposite angle A is little a. Let's get to work. Opposite angle B is little b. So little b has a different name. What's the different name for that side? Well, the AC, the capital. What's the other name for little a? CB or BC. Okay. And here's little c. What's the opposite? What's its other name? BB? AB.
I said it.
I know, but you had your hand triangle so I couldn't hear what you're saying. Okay, don't forget triangles add up to 180 degrees. Sometimes we use that in this unit as well. Okay. So we have to know that sides, which sides correspond. We have triangle box, BOX. It's similar to, this little symbol means similar to, triangle cat, CAT. So let's first of all talk about corresponding angles. We can say that angle B equals angle C. Why? Because they're the first letters in both names. Corresponding angles must line up. So what about angle O? What angle is equal to angle O? Good, because they're the middle letters. What about angle X? Angle T. Now you can do the same thing. So to show that these are equal, we would have the same markings. So a dot for angle B means angle C must have a dot because they're the same size. If O had an open circle, A must also be marked the same. For angle T, let's use an angle symbol with a line, then X would be an angle symbol with a line. So you can look for same markings to show that angles are equal. Brody. Corresponding means that they match up. So imagine B was shrunk down, C is the old B is the old C. Oh, you okay with that? Yeah, I know. So then we can also match up corresponding sides. We can do that from the name as well.
So when you change, if you have the same...
Okay, I'm back to using my Walmart computer. As Brody would say, this is being recorded, Brody. Anything else you want to add to your parents? Fine, Mike, seriously. You're not going to get me in trouble. I can do what I want. Okay, so back to the drawing board. BO, just like Brody, is similar to CA. So we can see BO is similar to the sides CA. Quiet, listening. These sides correspond because they're contained by the same angle. Dot, open circle. Dot, open circle. Just like, and in the name, they're the first 2 letters. Okay. The last 2 letters are BX and CT. So we can say BX, write this down, don't just stare at the screen, folks, is similar to CT. Those are corresponding. That means they've been enlarged or reduced at the same ratio. So BX is here, it's being reduced or to CT. They correspond. And the last ones that correspond will be in the similar spots in the name as well, OX and AT. So OX is similar to, I'll use the capitals, sorry about that. OX is similar to AT. Those are corresponding sides. Those are the sides that have shrunk or been enlarged. It's important to know which sides correspond because that'll set up the ratio correctly. So let's practice setting up the ratio correctly. We want to find out if these triangles are similar. So what we should find is that corresponding sides will give us the same number, the same ratio. Which triangle do you want to put on the top of our fractions, the left or the right? Left, sure. Then right will go on the bottom. So for the left triangle, we have 3, 2.8, 1.1. So for the right triangle, you have to match up the sides. Now notice we went from large to medium to small. It only makes sense that the other triangle matched up similarly. So in the other triangle, what's your largest side? So it should match with the largest of the other one. The medium size?
4.6.
And the smallest.
1.6.
Now I want you to take out your calculator and go top divided by bottom to figure out what the decimal is. Top divided by the bottom. I got 0.6 repeating. Try that for the other two, please, with a calculator. Calculator. Jessica, Simran. So you should have found that each one would give you 0.6 repeating. Remember, if that calculator rounds, you'll see a 7 on the end, but it's truly 0.6 repeating. Okay, you got to know what your calculator is doing. So, are they similar? Excuse me. Yes. No marks, because corresponding sides are equal. That's your mark. Now, truth be told, we didn't have to do that at all. Exactly. Have a look at your other rule, folks. Hello. Corresponding sides make equal ratios. That's what we tested. Well, what would be so much easier to see? Equal angles. How the look. Find all the angles, please. Oh, 69 and 180 minus 90 minus that horrible number equals 21 degrees. So, that was a little offside, Brody. That was over the line. So what do you say? Sorry, Mr. Barker. Thank you. So, again, you guys are talking, not sure why. So, for this triangle, we didn't have to find the corresponding sides. It's good to do that, because you can see them all being equal. But what we should say is yes, because angles are equal. That would have been a much easier answer. So look at the other triangle. Can we find all three angles on the other one?
Maybe.
Well, absolutely not. If I give you one, you can't find the other two. Only if I give you two angles are you allowed to use your triangle rule. So what you actually have to do for this one is truly find your ratios. Which triangle do you want on the top of your fractions, left or right? Okay. Right on the bottom. Doesn't really matter, you just got to pick one, okay? So for the left triangle, let's go 3.3, 3, 2.7. Now match up the sizes for the bottom, please. Use your calculator to find the ratios. Three divided by 4. Hope you don't use your calculator for that one. It's 3/4. But I'm sure you used it anyways. And the last one's like way off. Are these triangles similar? What's the reason? No. Yeah, because corresponding sides are not equal. Now, on the next side, I tell you that they're similar. The first thing I state is that they're similar. This is great because then you know you can compare side GE to KL. Right? You know then you have to compare HI to LM. So you know now what to compare. So let's set up your three fractions. That's what you want to start with all the time. So this is from that worksheet, right? Three fractions. Which triangle do you want on the top, left or right? Okay, right goes on the bottom. So for the left triangle, we have x, 2, 1.9. Now we don't know all the sizes. So x is between G and H. Which side corresponds? Looking at the name. GH corresponds with the first two letters, KL. So KL is going to be 10. It goes underneath. Then we have 2, which is GI. GI corresponds with, which is 8. Okay. And now we have 1.9, which is HI, LM. Okay. And so we 7.6. Now you could have x over 10 equal to the first one or the second one. Let's not work too hard. Let's just use this one. Cross multiply, find the value of x. Go. Okay, look at the next one. So we have these two triangles being similar. When triangles overlap, you got to watch your dimensions. Because AB is clearly x, that's no problem. Well, what's the length of BC? It's not 7.2, it's not 8.7, but what do you have to do? Add them. So draw a new triangle and then put the proper dimensions on. So for the bottom one, 7.2 plus 8.7 gives us this large side of 15.9. That's the number we have to work with. So you got to find that first. Okay. Now find the dimensions of this top one. $19.2. Now it'll be easy to set this up. Set up your three fractions. We have the small triangle right here, EFC. Let's put the small on the top and put the big on the bottom. Okay, go for it. Set up your three fractions. So x, 15.9, 19.2. Doesn't matter which one you put there. On the bottom, 5.4. 15.9 matches up with 8.7.
15.9 part of the big one.
Yes, it is. So
This one.
oh, I see what I did. I switched that up, didn't I? I put the small on top. Okay. Well, you should have recognized that. Okay, so I only need to set up one fraction. It doesn't matter if you have the same one or not, you'll still get the same result. Okay, so cross multiply, 5.4 times 15.9 equals 8.7 times x. Is that right?
No.
Yeah, I don't think I.
0.77.
Thank you. So times 15.9, then divide by 8. 7. That's better. 8. So what should we round to?
9.9.
9.9, not to 10. Nearest tenth. So remember, for decimal places, this is the nearest tenth. What's the next decimal place?
Hundreds.
100th. Okay. Good. Okay. Word problems. Now, most of your diagrams will be drawn for you, but some won't be. So here's your sun. Sun, Mr. Golden Sun, come shine on me. Oh, sorry. Okay, there's Cameron. He has a shadow. Where would you find your shadow? On the ground. Have a look right now. See where your shadow is.
I don't have one.
Yeah, really? Okay. So, the shadow of Cameron is 2.5 meters. Cameron is 1.5 meters tall. You need to put your numbers on your diagram. Here's the tower. It's a very special tower. It has a shadow of 5.8 meters. You want to know how tall is the tower. So we call it H, you can call it X, call it whatever you want. This one's kind of special. We only know 3 numbers, so you're going to get we know 2 fractions, so you're only going to get 2 fractions right away. So we can put H on top, which will make it so much easier. Figure out the bottom. Solve for H. Go. What goes underneath H? What goes underneath 5.8? Good. Solve for H. Okay. Who is the answer? Wrong. Oh.
The height of the tower.
Yes, you gotta have a sentence. It is a word problem.
No.
Tower is 3.48 meters tall. The sentence just helps you reflect to make sure you're truly answering the question that they're requiring you to answer. Bingo.
Will